Labs 3 and 4 use the same concept to test deflection of the beam, but give students a little more option in terms of how they're going to test. For instance, Lab 3 includes a stressed skin composite, where students add tape to one side of the beam in order to reinforce the beam's strength. For Lab 4, students get a chance to freestyle a bit and see if they can create the strongest but lightest beam they can. They could add rebar, for instance, in kebab sticks. They could do more stressed skin composites, or there are several options depending on what you're willing to let them make the beam from.
So in the stressed skin composite lab in Lab 3, we can vary the type of tape and the amount of tape, because the more tape that you put on here, the heavier your beam will be. And we can also bring in the cost factor of the tape to really make it a more true-to-life engineering exercise. And stress skin composites are what is used in aerospace design. The skin on the wings takes a lot of the stress. You'll also find it in a banana. And if you're not particularly handy and you don't have a bandsaw, so you don't want to cut up the insulation board, lasagna noodles work with the stress skin composite as well. Some of our examples that we were playing with of beams that we fabricated are straight Portland cement. This is very brittle, so you're not going to do a good flexion test on this, but you can crash test it. And in this sample, we've stirred in expanded polystyrene beads to reduce the mass of the Portland cement. And that's actually used to reduce the mass of cement. This was an example where we tried to keep the same geometry of the folded cardstock from Lab 1, and then we inserted spray foam insulation. And that worked fairly well. With different types of spray foam insulation, you can get different densities. And we were able to measure an effect on the slope of the deflection load curve depending on the foam density. This was a fairly expensive one that we made out of Uricast resin. It's extremely stiff and fairly heavy. So even though it's a polymer, it's quite heavy. I'm into found materials for lab samples. I know you guys are scroungers. Paper towel roll, piece of duct tape, my spray foam insulation. I can make a round beam. Another trick that we found is these silicone ice cube trays. You can make concrete beams in this and also polymer or Uricast resin samples in this. And if you are teaching material science and you're melting tin, you can actually make metal bars in these molds as well by pouring your tin into them. So those are some of the fun experiments that we've tried with this lab.
By the time students get to Lab 4, they're actually designing their own lab. So they're taking the materials and the shape into consideration to create a beam that they think will be the strongest and stand up the best. I have a competition against the classmates, and the students are gung-ho. This is a direct, absolute, concrete, get it, combination with the NGSS standards and students being able to design and critique their engineering practices.